All right, so this is an animated interactive video on the light independent reactions or the dark reactions, also called the Calvin cycle. So there's three big stages here. In the first one, we have carbon fixation. So carbon is going to be pulled from carbon dioxide, and the enzyme that is used to do this and start this whole cycle is called Rubisco. The second stage is called reduction, but really it's a rearrangement of these carbon based molecules. So I'm rearranging these atoms, I'm adding some energy, electrons, and hydrogen to form this molecule called G3P, which is like the precursor to all sugar and carbohydrate molecules, and it's actually used in combination with others to form some lipids and proteins. So this whole cycle will produce one glucose molecule. So this it will exit here and goes on to become glucose, and five others are going to be regenerated. So they're just going to continue in this process. So that's the third stage. Is I'm taking those leftover G3P molecules and basically converting them back into a form that looks like this, a straight five carbon molecule, so that it will fit back into my enzyme and I can use it to help fix carbon again. So let's take a look at this. All right, so the first step that starts the whole cycle is Rubisco is going to fix carbon. So it's catalyzing a reaction between this five carbon molecule and carbon dioxide. Here we go. All right, so that's the first part. And as it's fixed, you can see the five carbon is added to that last carbon from carbon dioxide. So I have six carbon molecules total, and they're rearranged to form three carbon molecules. And you don't need to know this really long name, just three carbon molecules are made. Okay, next I've got my energy coming in from the light dependent reaction. So my energy or my electron carrier molecules, NADPH and ATP, they're my fully charged batteries. And now I'm going to use them to transfer some of that energy, and really I'm modifying this three carbon molecule to become something called G3P. So the diagrams look really similar, but structurally, if we were to look at an atomic level, they are going to be different. This is my precursor to make glucose and all other sugar molecules. So here's how it works. That energy is going to be transferred. So ATP, when the energy is lost or dropped off, becomes ADP plus a phosphate. And now notice the NADPH. So it's losing a hydrogen ion on the end, and it's losing these two electrons to become NADP plus. There we go. Okay, so the NADP plus and the ADP are going to go back to the light dependent reaction. So they're really just shuttling back and forth, transferring energy. Okay, so let's finish this up. Oh, I got to get my electrons. So I'm taking energy from ATP, electrons from NADPH. Okay, now I've got my six G3P molecules, and we're going to have one exit. So my whole cycle, there we go, and the rest are regenerated. So they're going to continue through the process, but we still have to reform them so that they're five carbon molecules. So we're going to need ATP to do that. Anytime we're moving atoms, we need energy. So we'll drag this there. There we go. So I've used that energy. Now ADP and my phosphates are free. Those are going to go back to the light dependent reactions again. And now I've got my five carbon molecules. So they would be able to continue. See how they'll fit now with Rubisco, and more carbon dioxide would come in, and this whole cycle will continue.